In this video, we are going to review the four formulas for integrals. So what are the four formulas for integrals? So the first one is the general power rule. So what's general power rule? If we have a function to the nth power and also its derivative in it. So that's very important. Have the derivative also, then you can simply write this one as the just this is like very similar to xn integral. So we know that xn is x to the n plus 1 over n plus 1 plus c. That's the same idea here. So if you see the derivative, actually fx act like that. So fx acts like that, and then you're going to get this result. So which is fx n plus 1 over n plus 1. This is only valid for n negative n not equal to negative 1. So what's the second one? Second one is the exponential rule, and we also know the exponential rule, the general one, which is e to the x dx, which is equals to ex plus c. So you can see this exactly act like that. So if you have a function and also like you see the derivative here. So you see you have a function and the derivative. Function and the derivative. So if you see the function and the derivative, you can simply write it using, so it's simply going to be e to the fx. The reason is once you take the derivative, you can see you're going to get this one. So that's the idea. So you think backward. So that's the second one. And the third one. So third one is the, so you have a function and the derivative is on top. So if it is like that, so you know this result. So what's the result? If you take the integral of 1 over x dx, so which is equals to the ln absolute value of x plus c. That's the same idea here. But if you have the function and its derivative on top, you can write this answer as ln absolute value of x. So that's the third one. So what's the fourth one? So the fourth one is, so this is also a case of number one, but it might be very useful if you remember this as a separate case. So what is it? So you have ax plus b to the nth power, then it's just like a regular power rule, but what is missing is a. So what will happen is you need to divide by a, and also you want to divide by n plus 1. So it's going to be n plus 1, n plus 1, and plus c. So it's also valid only when n not equal to negative 1. Negative 1 is case is considered in part 3. So these are the four formulas for integrals, and if you remember, then you can save a lot of time. So we can do a few examples to show you like how quickly you can do certain problems if you know this trick. And also you can prove all of these using the substitution method. So try to do that. So just use the fx as u, and then see whether you can prove this using the substitution method. Okay, so let's try to look at some examples now. So let's start with the, as the first example of this type, we can look at this integral. So we have 6x square, 6x times 3x squared minus 5 to the 17th power. And then if in this problem, you can see this is like type 1 here. You can see if you look at the derivative of the inside function, which is 6x. So you see the derivative, you see the function here, and then you see the derivative there. So that means you can simply use the general power rule for this one. That's not, equation number 1. So if you use that, then you can simply create the fx function just as a regular x. So that means the answer is going to be 3x squared minus 5 to the 18th power, because you add 1, and divided by 18 plus c. So that is the answer if you use the for formula part 1. So let's look at the second example. As the second one, we have 6x cosine 3x squared minus 5 dx. And you will see that this is not exactly the formula type, but still we can have the same argument here. Because the idea is, you can see the inside function is the same one as before, and then the derivative of the inside function is 6x. So that means we can simply treat this function just as a regular cosine. And we know that the integral of cosine is a sine, because when you take the derivative of sine, you get the cosine. So that means the answer is simply going to be sine 3x squared minus 5 plus c. So that's the answer. So you can see, so you think backward, that's the easiest way. Think backward and see. So you notice that the derivative of this function is the is this one. So that means we can write it like that. Okay, so let's look at the next one. As the third one, we have e to the secant u times secant u tan u. And then you will notice that so derivative of the secant function is, derivative of secant is secant tan. So that's the derivative. So this is the function and this is the derivative. So that means we can use the 4 formula trick for this one again. So answer is going to be simply e to the function. So e to the secant u plus c. So you can see you can get the answer really quickly if you know this trick. So let's go to the fourth one. As the next one we have the integral of x over 5x squared plus 7. So this is slightly different from what we had earlier, but still you can see this one going to match with one of those forms. So this is the third one. So you have a function and its derivative. So if you look at the bottom function, the derivative of this one is 10x, but we only have x here. That's okay because you can always manipulate numbers. So what we're going to do, we're going to use a simple trick here. So the first step is we are going to get 10 here. So what we do, we're going to multiply by 10 and divide by 10 at the same time. So it's like 1. And then x over, you can see 5x squared plus 7 dx. Now you can see we have the formula that we need. We have a function in the bottom, the derivative on the top. So that means this is simply going to be the natural log form. So that means the answer is simply 1 over 10 natural log of the function, but you can see this function has a positive sign and also it's always positive, so you do not need a parenthesis here. So you don't need the absolute value here, so you can just say 5x squared plus 7 plus c. So that's the answer for this one. So let's look at the next one. As the next one, we can look at the integral of 3 over 7t plus 4 squared dt. And then also you need to get used to like other variables. That's why I'm using like t, u, x and all of them, because you need to get used to it. So how you do a problem like this? So you can see this is like type 4. You have a x plus b form. So if you get a problem like that, first thing is notice what is the derivative of the inside function. The derivative of the inside function is 7, not 3. So what we're gonna do is the first step is we're gonna take it out. So you're gonna multiply by 7 and divide by 7. That's what we do. So we can multiply by 7 and divide by 7. And then also we're going to bring that term to the top. So we can write this one as 7t plus 4 to the negative 2 dt. And then what you can do is now we can just use the rule. So rule number 4. So you can see it is 3, 7. We have that. And then since this is the derivative, so you can simply create this function just like x. So that means it is going to be 7t plus 4 to the negative 1 divided by negative 1, because you're going to add 1 plus c. And we are not going to leave it like that. So we're going to write in like a better way. We can write 3 negative 3 seventh, and then you can write 1 over 7t plus 4 plus c. So you can leave it like that, or you can actually multiply inside. So you can also write this one as negative. You don't have to, but you can do 3 over, if you multiply by this one, you're going to get 49t plus 28 plus c. So you can leave it like that. So both are okay. So you can write either this or that in exam. Okay, let's go look at the next one. So as the next one, we have like an interesting problem. So what we have is 1 over 1 plus x squared times square root of tan inverse x. Tan inverse means arctan. So tan inverse is the inverse tangent. So this is also like very similar. So so this again the general power rule, like part number like 1 is a problem type 1. So we're gonna take the function to the top. So we can write this one as tan inverse x to the negative 1/2. And then we have the derivative, that's the derivative of the inside function. So that means we can simply treat this like a x. So we simply treat this one like x, that's the idea. So if you treat like that, so you can see the answer is going to be simply tan inverse x. You're going to add 1, so it's going to be negative 1/2, going to be positive 1/2, and divided by the same number. So that's the answer. So that means you can write this one as 2 tan inverse x square root plus c. Could divide by 1/2 means multiply by 2. So that's the answer. So let's do another one like a definite integral. These are all indefinite. Let's do a definite integral one. So as the next one, we have like a really interesting trigonometric one. So it is 0 to pi over 2 sine theta over 1 plus cosine theta. Again, now we use a different variable. So theta is a Greek letter. So what we do here, you can see this is the function as fx part, and the derivative of that function is we know that the cosine derivative is negative sign. So we almost have that negative sign. You can manipulate the negative sign. So that means this is simply the derivative. So what we do first, we can write this one as um, 0 to pi over 2. That's the row or numbers we have, and the function is 1 plus cosine x. Not x, 1 plus cosine theta. Use the right variable theta, and then derivative of that is negative sine theta. So what we do, since we have only theta here, we put a negative sign in front. So we put a negative sign inside and negative sign outside just to match them. So you can see they are equal to each other and d theta. Now you can see we have the function here and we have the derivative there. So that means this is simply the third type, the log form. So this is the type 3, the log 1. So that means it is negative, a natural log, and then 1 plus cosine theta. If you are not sure, put the absolute sign here, and then we can evaluate at pi over 2 and 0. So if you do that, so you get negative. So let's plug in pi over 2 first. So it's 1 plus cosine pi over 2. Cosine pi over 2 is 0, so this is gone. And then you get ln1, which is also 0. So that means this is 0. The first term is simply going to be 0. And then minus, so it's become plus because there's a minus sign in front. So it's going to be plus now. The second term is ln 1 plus cosine 0. Cosine 0 is 1. So this is 1. So that means finally the answer to this problem is going to be ln 2. So ln 2 is the answer for this one. So let's look at one more problem just to conclude this one. So the next one, as the last one, we have this interesting one. This is really interesting. And you're going to see this is the function. It's a function. It is in the denominator already. And what's the derivative of this function? This is the derivative of this function because we know the derivative of ln x is 1 over x. So it's kind of hidden what we have here. So this is simply going to be natural log of natural log. It's kind of interesting. So, and then that's it. And then we can evaluate this one at e and e squared. So that means if you plug in the values, so you get ln e squared. This is going to be 2. This is simply 2. And then minus, you get ln e. Ln e is 1. So this is simply going to be 1. Because of this is 1, this whole thing is going to be ln 1, which is 0. And then so the final answer is going to be again ln 2. So it's the same answer as the previous one. Okay, so these are like some common problems that you can do using this trick, and you can see like we solve more than 12 problems in less than 10 minutes. So you can see it's really quickly like quick argument, and if you remember this one, you can solve so many problems using quickly, and it's going to be really helpful in exams. So this is like a shortcut for substitution method. So this is a shortcut for substitution method. Thank you.